We're going to continue working with exponents in this lesson instead of working with multiplication. We're going to be working with division. We're going to learn 2 additional rules in this lesson. So our first problem looks like this. X to the 5th over x cubed. The numerator is telling us that there are 5 x's. The denominator is telling us that there are 3 x's. When the same variable is repeated in the numerator and the denominator, they can reduce out. So these x's cancel each other out, these cancel each other out, these cancel each other out. You can see that there are 2 x's left in the numerator. And there's nothing left in the denominator. So our answer would be x squared. This rule is called the quotient of powers property. And it states, to divide powers having the same base, you're going to subtract the exponents. Okay, so instead of writing this out the long way, you can see that I have the same base. They're dividing, so you just subtract the exponents, you'd be left with 2. Let's do some more examples. Let's try 2 to the 4th over 2. The 2 in the denominator just have an exponent, that's 1. Because they're the same base, we can divide, and we get, or we can subtract the exponents, and we get 2 cubed. We have -3 to the 10th power over -3 squared. Again, these 2 have the same base. They're dividing, so we're going to subtract their exponents. The base stays the same, and you subtract their exponents. Okay. Let's get a little harder here. Let's try 9 to the 4th times 9 cubed over 9 squared. You cannot forget about the 3 rules that you learned in the previous lesson. Because in this problem, you're going to have to simplify the numerator before you can divide. So in the previous lesson, we learned if you're multiplying the same base, you add the exponents. So I get 9 to the 7th over 9 squared. Now that we're dividing and they have the same base, we subtract the exponents, so we get 9 to the 5th power. Okay. How about 1 over x to the 4th times x to the 6th? Okay. So for this problem, I see I have a fraction on the left side, and then a whole number would be on the right side. In order to multiply these, I would have to turn both of them into a fraction. So I put this in the numerator, and I put this over the line. Now I'm going to multiply the numerators. In the numerator, I have x to the 6th. In the denominator, we have x to the 4th. I see that they're dividing the same bases, so I subtract the exponents. X squared is our answer. Okay, I have 4 problems for you to try. I would like you to try -4th to the 11th power over -4 and x squared times x to the 11th over x cubed, and then 1 over 9 squared times 9 to the 5th. I guess I only have 3 problems for you, but you need to push pause and try those now. Okay. This is what our next rule looks like working the long way. Let's say we have a fraction. This is supposed to be a parenthesis. A over B fraction is cubed. So this cube, the exponent, is telling us that this is being multiplied by itself 3 times. So this really says a over b times a over b times a over b. So really, we have 3 a's and 3 b's. This rule is called the power of a quotient property. And it says to find the power of a quotient, find the power of the numerator and the power of the denominator and divide. Find the power of the numerator and the power of the denominator and divide. So this works similar to the distributive property. If there's a cube on the outside, that cube gets distributed to the numerator and the denominator. And then if possible, if these match, you could divide. Okay, so let's try 3 halves to the 5th power. This tells us to distribute the 5. We have 3 to the 5th and 2 to the 5th. Okay, and I'm going to stop right there. I'm going to let you know on your assignment when you should finish like this or when you should simplify further. The next problem says negative 7 over x, and that whole thing is squared. You're going to distribute the numerator and the denominator. So because this squared belongs to the 7 and the negative, I'm going to put the negative 7 in parentheses, so both of them are going to be squared. And then x squared. I would like you to try c over d to the 6th power and negative 2 over y to the 4th power. Okay. We're going to combine all of these rules together next. So let's say we have 2a to the 4th power over 4b, and that whole thing is cubed. Like I said in the last lesson, generally you're going to want to start on the outside and work your way to the inside. So I'm going to start with that cube and distribute it to the numerator and the denominator. That's a real good class somewhere. Here I'll have 2a to the 4th. That quantity is cubed. And then 4b, that quantity is cubed. Now I have to use a rule that I learned from the last lesson. It said when you have a cube on the outside, you're going to distribute it to both factors. On the inside, I have 2 factors here. So here I'm going to get 2 cubed, and a power to a power we multiply. So I have a to the 12th. And again, I'm going to distribute this 3 to both these factors. I get 4 cubed and b cubed. We're going to keep rolling here. I can simplify the coefficients out in front, these numbers out in front. So 2 cubed, 2 times 2 is 4 times 2 is 8. And then 4 times 4 is 16, and 16 times 4 is 64. Okay. In this lesson, you might be able to go further. This might be your answer, you might be able to go further. You can see I'm looking at the variables, that the a and the b are not the same variables, so I cannot subtract their bases, or their exponents. So the a and the b are as far as they can go. But the 8 over 64, you have to think of this as a fraction. I'm thinking of it as 8 over 64. I can reduce that fraction. I can take an 8 out of the numerator and an 8 out of the denominator. 8 divided by 8 is 1, so in the numerator I can have 1 8 to the 12th, or just 8 to the 12th. And 64 divided by 8 is 8. And then that's as far as you can go. Okay, let's try another one. X cubed over y. That quantity is to the 7th power times 1 over 3x to the 8th. I kind of have two problems in one here. I'm going to work with this problem on the left-hand side first. And I'm going to distribute that 7 to the numerator and the denominator. So power to a power we multiply. I'm just going to copy down the right-hand side. Now I'm going to multiply straight across. So I have x to the 21st times 1. Here I have y to the 7th, 3x to the 8th. There's no common bases. I can't multiply anything or add any exponents. So when this happens, you're going to want to list the number first, the coefficient first, and then list the variables in alphabetical order. So I have x to the 8th and y to the 7th. Here I see that this has 1 over 3. I can't reduce this. Then I look at the x's. Because they have the same bases, we can subtract them. 21 minus 8. Because there are more x's in the numerator, this stays in the numerator. And then y has nothing in the numerator, so that just stays. And that's as far as you can go. Okay, I would like you to try these two problems. 3x squared over 4y, that quantity is squared. Then we have 2x over 3t. That quantity is cubed. T to the 5th over 16. Make sure you're writing down any questions that you may have so you can remember to ask them tomorrow in class.